Hello, Latin geometry students. In this assignment, we are going to talk about polygons. Polygon is a category of shapes. See, shapes is not very specific. All the pictures you see up on the screen right now, these can all be shapes, but polygons are a specific type of shape. To be a polygon, we need to be a closed shape with straight sides. What does that mean? Well, real simple. Closed means the shape is finished. It's completed. It's easier to show you than to explain it, but on the left here, these are examples of closed, completed shapes. But on the right, these are not closed shapes. We don't like these ones that have little gaps in them that aren't finished, so we don't use these. We only talk about closed shapes. All right, next, to be a polygon, our shape has to have straight sides. In other words, no curves. That means exactly what you think it means. All these ones here on the left, these are good. They have straight sides. But all the ones on the right with curves, those are bad ones. Those are not polygons. We want to talk just about polygons. Why? Because we keep it to just polygons, we can have some pretty simple rules for figuring out things about those shapes. So up on the screen, these are all examples of polygons. What do they all have in common? They're all polygons. They have straight sides and they are closed. Okay, now, there are two types of polygons. There's convex, those are good shapes, and concave shapes. And again, it's going to be easier to show you than to explain it. But this shape over here on the left, this is a good shape. It's convex. This one on the right is concave. It's a bad shape. What makes it bad? Well, the fact that right here it dents in, it bends in towards itself. That's a concave shape, a shape that we don't like. All these up on the screen are concave shapes. These are concave because each one of them has a place where the shape bends inward towards the center. There's a couple different ways to describe it. That's not really a formal definition. There's a couple ways to describe it. In all these, one way to describe them is saying that they all have an interior angle more than 180. Or the traditional way to define it is to say if you could find 2 points in the shape and then when you connect them, the line has to go outside the shape, then it's a bad shape. These are concave. And this one, and in the top right, and the bottom, and the other one in the bottom, these are all concave or bad shapes because we can do this. You can also think of it as a third way to define it, whereas a concave shape, if you trace all the sides and lengthen them, there's places where the lines go back inside the shape. And that happens in all four of these, which is also what's making them bad. These are all okay ways to describe a concave shape, but the way I always think about it is if you have a shape, if it's a real object, and you put it on a table, if you can put it on the table so that there's a gap underneath it, then it's concave or bad shape. That's concave. We do not like concave shapes. Concave is bad. We will only talk about convex shapes. So in this case, we have a concave shape. This is a bad one. What do? Do we come up with a new set of rules for this? No, we just draw a little extra line through it. And instead of saying we have one concave shape, instead we say, well, we have two triangles that are just touching each other. And we find the properties or the rules based on the two separate triangles, and then usually just add them together. Okay, so up on the screen, there are 9 shapes. 4 of them are good convex shapes. Which are the good shapes? And the good ones are problems 4 and 5, and then 7 and 8. Those are the good ones. The rest of them have a place where they bend inwards. By the way, numbers 2 and 3 aren't even polygons. Why? What's wrong with these? These two have curves, so we don't like those for multiple reasons. Okay, concave shapes are ones, just don't talk about them. They're kind of like the weird cousin in geometry you don't talk about. You should know what I'm talking about. We all got that weird cousin we don't talk about. If you don't know what I'm talking about, you're the weird cousin that your family doesn't talk about. Okay, so now back to 2nd grade math. We're going to name our shapes. We do have to know the names of these shapes. So this is a polygon with 3 sides. What do we call that? That is a triangle. 3-sided polygon is a triangle. What about a 4-sided polygon? Quadrilateral. That literally means quad is 4, lateral is side. It literally means 4 sides. This is not a square or a rectangle. Just 4 sides is quadrilateral. How about a 5-sided shape? Pentagon. 6 sides. Hexagon. 7 sides. All right, this is one that people generally don't know, and there's 2 good answers for this. A 7-sided shape is either called a heptagon or septagon. But the heptagon or septagon is a 7-sided shape. You'll have to be able to recognize that word. An 8-sided shape we should all know because it's a stop sign. You should know this. Same as an animal with 8 legs. That is an octagon. A 9-sided shape, a word that most people don't know, is called a nonagon. And a 10-sided shape is a decagon. All those come up often enough that we should know them. There are other shapes. There's a shape with 11 and 12 and 48 and 137 sides. But when we get past 10, we have a shortcut for naming them. We call them n-gons. What's that mean? Well, it means if you have a 11-sided shape, you could go ahead and Google its name. It's got one. It's a hen decagon, but nobody remembers that. So we just call an 11-sided shape an 11-gon. What do we call a 23-sided shape? It's a 23-gon. Again, all these shapes have other official names, but people tend not to remember them. You can even go to Wikipedia and look up list of polygons, and it's got a name for every polygon up to 90 million sides, and the names are pretty crazy. So that's why we just use the n-gon thing. The next thing you need to know is the word regular. Regular shortens up some of the vocabulary we have to use. When we talk about a regular polygon, we're talking about a polygon where all the sides and all the angles are congruent. When we say a regular polygon, we're talking about what you think of when we say the word pentagon. Here, right in the center here, this is a regular pentagon. You can have irregular pentagons, but regular means all the sides and all the angles are congruent. Like over here on the left, regular pentagon. Everything is the same. It's really symmetric all the way around. And on the right side, that's an irregular pentagon. It's all messed up. When we say something is regular, we mean it's equilateral and equiangular. This is very common, so we shorten it down to one relatively short word rather than write out equilateral and equiangular. Okay, now, every polygon has the same couple parts. We have the sides, which are the segments that make up the edges of the triangle, or of the polygon, and the corners, which we call vertices. Each corner is a vertex. If you have more than one of them, it's vertices. Finally, naming a polygon. To name a polygon, it's a little bit confusing. When we first named a triangle, you could just name the three sides in any order you wanted, unless you were writing a congruent statement and you had to match stuff up. But when we name other polygons with more than three sides, you have to follow a specific set of rules. You have to start with a point. Any point you want. You can pick any point you really want to start, and then you name the other points as you go around the shape. Clockwise or counterclockwise, it doesn't matter. So I could call this shape heptagon BCDEFGA, or I could start somewhere else and go the other direction. I could call this heptagon FEDCBAG. Because of this, there's a lot of different names for this thing. In fact, there's 14 different names for this heptagon. So we just do our best to try to do it alphabetical just to avoid confusion. So the best name for this one is heptagon ABCDEFG, even though the other ones are not wrong. Okay, so words you should know by now. You should know what a polygon is. It's a two-dimensional shape that's closed and has no curves. Closed means that it's complete. Straight means there's no curves. Vertex is a corner. A side is the line segments that make up the edges of the polygon. Interior and exterior we're going to get to in a minute, but interior means inside and exterior means outside. Convex is a good shape that does not bend inwards. Concave is a bad shape that does bend inwards. And regular means both equilateral and equiangular. All the sides and angles are congruent. So what are we going to do with all these shapes? Well, we started with a triangle way back when. And if you remember, the first thing we learned about a triangle is what these angles add up to. The first rule we had about triangles is that the angles add to 180. And we used that to figure out everything else. All this trigonometry and stuff came afterwards. So for this hexagon and the other shapes, we need to start with figuring out what the angles add up to. Now, rather than come up with a separate set of rules for each shape, basically we're going to take each shape and just turn it into a bunch of triangles and figure out all the rules in the shape based on how many triangles are in it. The way we do that is start by picking a point, one vertex. Any of the vertices would be fine. You pick one of them and you draw in all the diagonals in the shape that connect to that vertex. And now, if you look, we took our six-sided hexagon and we broke it up into 4 triangles. Each of those triangles is 180 degrees. So the hexagon is 180 for each triangle times 4 triangles. So we have 4 triangles times 180 degrees each. That is 720 degrees. This is the same for every hexagon. The angles inside a hexagon always add to 720. And that's what we do with all the shapes. They are all based on the fact that the angles in a triangle add to 180. So here we have a quadrilateral, a pentagon, a hexagon, and an octagon. If we want to know how many degrees the angles add up to, the interior angles, what we do is we draw in diagonals. and break it up into triangles. Here, this four-sided shape got broken up into two triangles. Our five-sided pentagon gets broken up into three triangles. Our six-sided hexagon gets broken up into four triangles. And our eight-sided octagon gets broken up into how many triangles? It's going to be six triangles. There's a real simple pattern here. However many sides the shape has, if you subtract 2, that tells you how many triangles are inside the shape. So the 8-sided shape, 8 minus 2 is 6. There are 6 triangles. If the shape had 20 sides, we'd subtract 2. There would be 18 triangles inside. And now for each triangle, each one is 180 degrees. So for the quadrilateral here, 180 plus 180 gives us 360. For the pentagon, 180, 180, 180, that adds up to 540. We already did the hexagon. It's going to be 720. So what do the angles of this octagon have to add up to? Well, 180 times 6 triangles, and we're going to get 1,080. So our rule for what these angles on the inside of a shape add up to, we always do the same few steps. Number one, we got to figure out how many triangles the shape can be broken up into. And basically, that's always how many sides it has minus 2. So the first thing you got to do is count up how many sides your shape has. So we count up how many sides our shape has, or if you remember the names and it says this is a decagon, you would already know it's 10. So we take 10 and subtract 2, and that's 8. There are 8 triangles inside this decagon. Then we just multiply that by 180. 8 times 180 is 1,440. That's what these angles on the inside of the shape add up to. Take the number of sides, subtract 2, multiply by 180. We simplify that into a formula, n minus 2 times 180, where n is how many sides the shape has. So however many sides it has, subtract 2, and then multiply the result by 180. That's what the angles add up to. So what do the angles of a pentagon add up to? Well, a pentagon has 5 sides. So we do 5 minus 2 and multiply by 180. That'll be 540. For an octagon, we do 8 minus 2 times 180. That will be 1,080. What about a heptagon? Well, the heptagon has 7 sides, so plug it into the formula. 7 minus 2 times 180, and we'll get 900. And finally, a 20-sided polygon, what will the interior angles add up to? We do 20 minus 2, that's 18, times 180, we get 3,240. That's the angles on the inside. We're also going to talk about the angles on the outside, what we call exterior angles. So first off, what are exterior angles? No problem. That's if you take the sides of the shape and extend them, so we get all these extra lines sticking out of the shape. And the exterior angles are all the angles on the outside of the shape. These exterior angles just always add to 360. There's no formula you have to do this. They just add up to 360 no matter what the shape is. So the exterior angles add to 360. Does not matter how many sides it has. It's always 360 for the exterior angles. So what do the exterior angles of a pentagon add up to? And an octagon and a heptagon and a 20gon? 360, 360, 360, 360.